All right. Good morning, everyone. Good to have you all join us today. We got 4 people watching. We're just gonna wait around 2 minutes and then we're just gonna get started. Um, yeah, it shouldn't be significantly difficult, I don't think. Um, so it's just going over some basic stuff, and then once we go over that, we're pretty much set. Um, well, I don't want to say basic, but I think you guys get the idea. We're essentially just going over our 7.5 lesson, which is pretty short, is what I meant by basic. And then we're done for today. So office hours will be tomorrow. For those here right now watching, you guys get the best announcement, which is that your quiz has been pushed to Friday. So there's no lesson on Friday, so we'll have office hours tomorrow, and then you'll have your quiz on Friday to complete, and then over the weekend you'll have a pretty chill time. We're going to start chapter 8 on Monday next week. Okay? So that's going to be our plan. If you have any questions, please feel free to let me know. You got 5 people watching. Just gonna wait 1 more minute, and then we're gonna get started right into it. We're gonna get right into it. So the sheet you should have open right now is this one. You were supposed to print it yesterday because I thought we can kind of go over it, but I felt like it was a little too much information, so I decided not to. So we're just slowing down the pace. Okay. All right. So it says determine the missing angles on the triangles below. So it's asking us to determine missing angles here. So yesterday, when we went over SOHCAHTOA, right? Let's write it out here, so we know. This is the information we learned yesterday, and that information doesn't change today, right? That information stays exactly the same. We're still going to use this concept of SOHCAHTOA for this lesson, okay? The main thing that you need to know is that when we are determining missing sides, we need at least 2 sides. If we're missing like a side, so if we only have one, we can't solve for the angle, right? So when it specifically asks us to solve for the angle, we need to have 2 sides and check for 2 sides. Now the good thing about right angle triangles is if we have 2 sides, we can already find the third. So that's not an issue, and you should know that because you know the Pythagorean theorem, which is a squared plus b squared equals c squared. But we're not going over that. We're going over how can we use SOHCAHTOA to solve for an angle instead. So looking at example A, we first indicate what angle are we solving for. We're looking for this angle here, right? This is the angle we're looking for, and then we ask ourselves, where's my hypotenuse, where's my opposite, and where is my adjacent? So my hypotenuse is here, opposite of the right angle. My opposite side is here, the other side of the angle, and then my adjacent is the side beside the angle, right? So we have those 3. We write those down so that we have it as reference. Once we have those down, then we can say, hey, okay, we have our 3 sides. What are the 2 sides that we know? So we know the adjacent and we know the hypotenuse. And so thinking of SOHCAHTOA, which one has adjacent and hypotenuse in it? And the one that has it is cosine, CAH. So cosine is equal to adjacent over hypotenuse, contains what we need. So I'm going to write out cosine theta is equal to A over H, which is adjacent over hypotenuse. Once we have that, we're going to fill in our information. So we have cosine theta is equal to adjacent, which is 9.7, over hypotenuse, which is 17. Okay? So cosine theta is equal to 9.7 over 17. Now you can solve that fraction, but we need to solve for theta, which becomes an issue. There's a cosine there. So now we're going to be unlocking another function on your calculator. What's going to happen is we're going to make theta alone. In every mathematical operation, addition, subtraction, multiplication, division, they have their opposites, right? Addition has subtraction, multiplication has division, exponents have roots, and trig has inverse trig. And what that looks like is this. Cos inverse of 9.7 over 17. Let me show you on a calculator. I'll use my phone calculator to show you. So normally, you would press cosine and you would get this. The difference is, on your scientific calculation, you should see a second floor button, right? If you see a second floor button, if you look here, it says sine, cosine, and tangent. Let me see if I can lower the brightness a little so you guys can see a little better. There we go. That's better. So you have sine, cosine, and tangent at the bottom here. Okay. If you click the second floor button, you'll see that the sine, cosine, and tangent are now sine inverse, cos inverse, and tan inverse. So we're going to be using these inverse functions when we are solving for angles. So we're going to click cos inverse, and you're going to get a cos because that's the actual mathematical term for it. And we're going to type in 9.7 divided by 17. So we're going to type that directly into our equation, and we get 55.2. And so theta is approximately equal to 55.2 degrees. And that's important that we know that the units, because it's an angle, is degrees. Okay? Make sure your settings are on degrees. You don't want it on radians, right? Make sure it's on degrees. And you should get 55.2 degrees as your answer. Okay? Let's move on into the second example here. We have this triangle here. We have this angle here. So writing out our sides, we have hypotenuse, we have opposite, and we have adjacent. Right? Hypotenuse is opposite of the right angle, opposite side is opposite of the angle, and then adjacent is the side beside the angle. And the sides that we know are hypotenuse and opposite. And which trig ratio has that? Is it sine, cosine, or tangent? It would be sine. So we have sine theta is equal to opposite over hypotenuse. So plugging our values in that we know, opposite is 12, hypotenuse is 21. So we have sine theta is equal to 12 over 21. And we can get theta alone by doing sine inverse of the ratio and solving that. So once again, bringing out my calculator here, I'm going to type in second floor, sine inverse, 12 divided by 21. Making sure that the fraction is in brackets because we want that division to go first, just in case some calculators mess that up. Right? There are different calculators that may calculate it differently, so make sure that's in brackets. So then when we do that, we get 34.85. So 34.8. So it's approximately equal to 34.8 degrees. And there we have it. Okay. Next up, I'll leave that for a little bit. We have 2 more questions and then we have 4 more questions and then we're done our lesson for today. I'm going to quickly give you, for this last question, question D, I'll give you like a minute. I'll give you 2 minutes to try to solve both of those angles because there is 2 angles here. Okay. But that's fine. Okay. Now for question C, it doesn't indicate what angle we want to solve for, so let's just pick this angle here. Let's say that's our theta. We want to solve for theta there. So setting it up, we have hypotenuse, we have adjacent, and we have opposite. So we write down our 3 sides as always, and then we think, okay, what do we know? We know our opposite and we know our adjacent. So which trig ratio is that corresponding to? That's tangent. Tangent is equal to opposite over adjacent, TOA. So tan theta equals opposite over adjacent. And so when we plug that in, we're going to get tan theta is equal to 3 over 6.5. That's going to give us theta is equal to tan inverse of 3 over 6.5. And so once again, pulling out my handy dandy calculator here. Let's shift that up a little bit. Handy dandy calculator, I'm going to type in tan inverse of 3 divided by 6.5, and that's going to give me 24.5. So theta is equal to 24.5 degrees. Okay. So what I would like you to do, I'm going to zoom out just a little bit. What I would like you to do, I have all the other examples there. I would like you to solve question D for both angles alpha and beta. Okay? So angle alpha and beta, you're going to solve for these 2 angles. I'm going to give you 2 minutes on the clock, 1 minute for each angle. Shouldn't be too bad. Okay? 2 minutes on the clock. And once you're ready, you can get started. Here we go. 2 minutes. So let's take a look at our final question here. I'm going to zoom in. Okay. So our final question D here solving the two angles. So let's kind of separate it into two sections here. So I'll work on angle alpha here. So looking at angle alpha, we have hypotenuse, that doesn't change. We have opposite here, and we have adjacent here. I'm going to just use the letters to indicate it because we do need space. Okay, so we have those three sides. We have adjacent and hypotenuse. SOHCAHTOA, cosine uses adjacent and hypotenuse. So we're going to write cosine of alpha. I'm going to use alpha this time because that's what they're giving us, is equal to adjacent over hypotenuse. So cosine alpha is equal to 5 over 34. And to get alpha, we got to cos inverse that. And that's going to give me cos inverse of 5 divided by 34. And that's going to give me 81.5 degrees. Okay. So there we have that one. Now, you can, if you solved beta using the trig formulas, that's good, and then maybe you solved alpha. Once you have one of the angles and I ask you to find the third one, you have to remember. Some of you may have forgotten, but the reason why I only gave you 2 minutes was because all the angles in a triangle have to add up to 180 degrees. That's something, once again, that we expect you to know as math teachers. So it's actually really easy. All you had to do was alpha plus beta plus 90, plus 90 is equal to 180. We know what alpha is now. And so we can quickly solve for beta by saying 180 minus 81.5 minus 90. And so beta, looking at our calculator here, so just quickly typing that in, 180 minus 81.5, minus 90 is going to give me 8.5. And so we get beta is 8.5 degrees. Now, if you did beta using and solving for beta first, I'm still going to go through that method, which is why I left this top space open here. If you chose beta, that means this would have been your adjacent and this would have been your opposite, which means you had opposite and hypotenuse instead. So if you solved for beta first, you would have used sine. So, right? SOHCAHTOA, so has O and H. So if you used sine beta, it's equal to opposite over hypotenuse, you would have gotten a similar answer. So if we kind of finish solving this one here, you get 5 over 34. Beta is equal to sine inverse of 5 over 34. And so beta is going to be equal to, and so we have over here sine inverse of 5 divided by 34, and look at that, round it up, will give us 8.5 degrees. And there we have it. So we still get the same answer if you used your primary trig ratio. If you did not, that's fine if you solve for alpha first, and this is always the alternative to finding the other angle, right? Once you have two angles in a triangle, you can always find the third one because all three angles in a triangle add to 180. All right, 2 more questions to go and then we're done. So solving triangle ABC such that A is 90, small a is 7.8, and small c is 5.2. So we don't have a triangle, but we can always draw one, and it's always suggested that you do. So we're going to draw a right angle triangle, doesn't matter how you draw it, and it says that A is 90, right? So it's a right angle triangle, but it specifies that capital A is 90, which means this corner is 90, okay? Which means opposite of that is A, small a, lowercase a. which is 7.8. Now we get to pick where small c goes. So maybe we want this to be small c, and that's going to be equal to 5.2, which means this is big C and this is big B. So we have triangle ABC here now. Once we have that written out, we can now, when it asks us to solve, okay? It asks us to solve, which means when I ask you to solve a triangle, you need to find every single missing angle and every single missing side. That's what it means to solve. So we're going to solve for angle C first. So I'm going to say first this is going to be hypotenuse, this is opposite, this is adjacent, according to that angle C reference. When we figure it out, this is a sine, so we're going to do sine C is equal to O over H, and I use C because that's the angle we're using. And then sine C is equal to 5.2 over 7.8, and so C is equal to sine inverse of 5.2 over 7.8, and C is equal to the inverse of that. So looking here, sine inverse of 5.2 divided by 7.8, and that's going to give me 41.8. So I get C is equal to 41.8 degrees. Now we know, or I've reminded you, that we can solve for angle B by just taking 180 and subtracting the other two angles, right? Because the sum of the three angles is equal to 180. So that means angle B is equal to 180 minus 90 minus 41.8. And doing that is going to give us 180 minus 90 minus 41.8. And that gives us 48.2. And so we have our second angle. Okay? We have our second angle here. Okay? Now, we need to solve for lowercase b. This can be done in two ways. Lowercase b can be solved using the Pythagorean theorem, a squared plus b squared equals c squared, or you can solve it using your primary trig ratios. Okay? I'm going to do both methods, right, just to show you. So technically, because we have a and c in kind of awkward positions where a is our hypotenuse in this situation, it would technically be this for us. So using the Pythagorean theorem, it would be 7.8 squared minus 5.2 squared, and we would square root that. So I get b squared is equal to 33.8 after doing the math on the right side. Square root both sides. And if I square root both sides, I get b is equal to 5.81 approximately. And that's going to be in centimeters. This is a typo. I noticed that that's meters. That should be centimeters. So ignore that. That should be centimeters as well. So 5.81 centimeters. Okay. Now, if we were to solve this using our primary trig ratios, right? If we were to solve this using our primary trig ratios, we would say, oh, lowercase b is our adjacent. We found angle C, right? So it doesn't matter which we use. You can do SOHCAHTOA. It doesn't matter which one. So maybe I'll be like, well, it doesn't matter which one, technically, yes. But if we want to solve for the adjacent, we want to use something that has adjacent in it. So we don't want to use sine. That's the only one we don't want to use. It doesn't have adjacent in it. So we want to use cosine or tangent. Anything that has adjacent we can use. So let's use cosine. So cosine of C is equal to adjacent over hypotenuse. Cosine of 41.8 is equal to B over 7.8. And so that's going to give us 7.8 cosine of 41.8 is equal to B. And when you solve that on a calculator, let's take a look here. So when you solve that on a calculator, 7.8 cosine of 41.8, we get the same idea, 5.81. And so that's the same answer that we got using Pythagorean theorem earlier as well. Okay? So there's your full solution to here. When I ask you to solve a triangle, I'm not asking you to solve just one thing. I'm asking you to solve every single missing piece of information within that triangle. So something as simple as this is worth like at least like 6 marks, just because of all the work that is required. Like 3 marks for setting up your trig ratio, 2 marks for understanding that you can solve it using your interior angle formula, and 2 marks for using the Pythagorean theorem. Right? So I think it's pretty fair. Like 1 or 2 marks for each of these, and total would be like 5 or 6 marks. Right? It's pretty quick once you get the hang of understanding how to solve for the angle or how to solve for the side. So I'm going to leave question 2 for you. I'm going to write the answers for you. Okay? I'm going to write the answers for you, but I'm going to draw out the triangle, and you're going to try it on your own along with the homework that is given. Wow, that is an ugly triangle, but that's okay. So this is going to be angle E here. It says angle C here. We'll make that here. That'll be 60 degrees. And lowercase e is opposite of side E, so that's 6 centimeters. So there's our triangle. That's what we know. We're missing 2 sides and 1 angle. And so maybe, I guess, this would be D, because it's CDE there. Okay. So once we have that, we can now solve for our 3 things that we're missing. So we're solving for, or your answers, you're looking for our capital D for the angle, lowercase d for the side, and lowercase c for the side. The answer you should be getting is 30 here, right? So copy these angles down somewhere so that you can check your work at the end of it. So you should get 30 degrees for angle D. Okay, 30 degrees for angle D. As for side lowercase d, it should be 3. And for side lowercase c, it will be 5.2. Okay? Approximately 5.2, rounded. So those are your 3 answers. So I would like you to try getting those on your own. Try it for yourself. See if you get the right answers. And if you do, that's fantastic. If you don't, feel free to give me a message on Google Classroom or contact me through email, and I will try to go over it with you with the detailed steps. Okay? So once again, with that, your announcements once again are, you have office hours tomorrow, so if you have any questions on any of the lessons we learned over the last 3 days, please come out and let me know so that I can answer your questions tomorrow. Maybe go over some textbook problems if you really need it, something like that. Second, your quiz has been moved to Friday, so you have an extra day to study, especially because our office hours is tomorrow. So please take time to study. Your quiz is just going to be on 7.1, 7.2, 7.3. And honestly, it might just be like 2 questions where I go, solve these two triangles, and that's it. Like plain and simple, as well as like maybe one or two similar triangle questions. So it shouldn't be significantly difficult. I don't think it's not going to be question heavy. It'll be pretty small, but it will still require you to have an understanding of your trigonometry concepts. Okay. With that, we are done. It was a pretty short lesson. It's 11:30, so please take the rest of the time to do the homework. Do the questions that that last question that we haven't solved, but I've given you the answers for. So give those a try, and I will see you tomorrow for office hours if you tune in. All right. Take care, everyone. Have a good one. Peace out.